Good morning, everyone. Welcome once again to our class for today. We continue our discussion on time series. We were using the BUD dataset last time, and we wanted to create a model for that time series. So just by way of quick review, we use these packages, forecast, FPP3, quant mode, etc. There are several packages that we are needing for this topic. Okay, I hope you have loaded these packages and required it. Okay, and then we said that we are using one of the most popular method in modeling time series, which is ARIMA, as developed by Bucks and George Bucks and I forget the name of Jenkins, the first name. Okay, and we're going to make use of the ARIMA model, where AR stands for autoregressive, MA stands for moving average. And we learned how the structure of an AR process, the structure of an MA process, and the structure of an ARMA process. I there stands for integration, which means you need to do differencing in order to convert your data into a stationary data. Because we said that ARIMA model, ARMA model will only work if the data is stationary. Okay, so last time, we learned how to make use of the quant mode package to download stock prices. So we defined the start date and the end date, and then we use this get symbols function where we identify the ticker symbol of the stock. Okay, the ticker symbol can be any stock. Any stock is identified by its ticker symbol. So for example, if it's Apple, it's AAPL. For Intel, it's INTC. For McDonald's, it's MCD. I mean, okay, and all the other stocks have their own ticker symbols. So if you're going to download the stock prices using quant mode, you have to know the ticker symbol. And then the default is downloading it from Yahoo Finance. Okay, but there are other sites that we can use to download data. So depending on the data that you need. So nowadays, it's not difficult anymore to download data, whether it's macroeconomic data, say GDP, GNP. You have FRED as a good source, the Federal Reserve of St. Louis. Okay. So for quant mode get symbols function, the default is source. The default is Yahoo. If you want, for example, to download from FRED, then you'll have to change this into FRED. Okay, so just by way of information, okay, for you to better appreciate a particular function, you can make use of the view. Okay. Wait. All right. So here, get symbols. If I click this, then Control Enter. Here in the help, my mouse is happened to my mouse. I'm sorry about that. My mouse is not working. Excuse me, class. Let me just handle this mouse. Okay, let me pause recording first. Okay, sorry about that, class. My mouse was acting up. Okay, can you hear me, class?
Yes po, sir.
All right,
Yes, sir.
so thank you. Let me resume recording. Oh, I wasn't able to pause recording. So there's a lull. Okay, so this is the get symbols function of the quant mode. And it pays to read, class. It pays to familiarize yourselves with the syntax of the function. Okay, and what's good about this is that there are examples here below. Okay, you can try to run. Okay, you can try to run this. You can even try to run this here, run examples, or you can copy it in your R script or in your R markdown. Okay, so that gives you a wealth of information about the function get symbols. So I hope you have run this already, the start date and the end date, and sometimes you might identify the date, but it will return. For example, in our case, I created this object bud, and if I view in this, okay, if I view buds, view bud, I'm getting here, the start date is 2009, July 1. It means that this stock, the data for this stock was not yet available on uh, January 1, 2007. Okay, so that's what that means. Let me just close. There are so many data that's open here. Okay, so that's what we did last time. We downloaded the BUD data set. Okay, and then we learned about the class of the data. It's an extensible time series. We said that an extensible time series is it's different from an ordinary data frame. So for example, okay, I'll need that again, the BUD data set. So let me once again print that. this one. So what's different about the XTS object class or the zoo object? If we compare this, let me, okay, let's take a look at the very common popular example in R. The iris dataset comes preloaded with R. So if I get the data of iris, okay, you will see that now iris is also in my data. Okay, and if I view this, let me just click this. Clicking this is equivalent to viewing this. Okay, there you can see it's run this code view, and then you see class. What's the difference between the iris dataset and the bud dataset? And one class, of course, aside from the variables. What's the main difference between the bud dataset and the iris dataset? Anyone? Okay, you may unmute yourself if you want. The index, yes, Jerome, could you explain? If you're going to share your answer, please. If you're going to answer, kindly share your answer to everyone. Jerome, can you unmute yourself, please? Ano yung difference?
Yes,
What's the
sir.
difference?
So, the index po for bud is 1, 2, 3. So it's numerical. Whereas
For
I mean,
iris.
sorry,
For
iris.
iris. Okay.
Whereas the index for bud is dates po, sir.
Thank you. That's perfect, Jerome. Thank you so much. That's correct. For bud, this is an XTS or a zoo object. Okay. The index is your time component. While for our iris, and if you get the class of iris, it's a data frame there. So that's the characteristic of the data frame. It's a rectangular data form. You have the columns with their names, the variables, and then you have your observations. Okay, so I hope you recall that. Now, for the bud data set, we said that through the quant mode package, the get symbols package, you'll be able to access the OHLC data, open, high, low, close, volume, and then adjusted price. Okay, usually for finance, what we're interested in is either the closing price or the adjusted price. So for this, we're just going to use the adjusted price. Okay, and I want to create an object that only contains the adjusted price. And what's the reason for that? Because we're just going to do a univariate time series analysis. We're not interested in the other data set. So if we're going to just maintain this data set, this time series data, and then just work on the last one, it will be quite cumbersome because we will have to identify which column or which variable we will be looking into. So the best way is just to generate another object containing just the column, okay, the bud adjusted that we're going to analyze. Okay, so one way to go about that, to do that is just to, okay, extract that specific column. So we said that the way to do it is to use the brackets. So since bud is a data frame, it means that it has both row positions and column positions. So having a blank here indicates that we're not filtering the row, but we're just filtering the column. So this means that we just want to create for bud, we want to filter just the 6th column. Okay, and here I'm creating a new object, add adjusted bud. You may name it any way you want. So I have already run that. I won't run it anymore, but I have here already the object adjust bud. So if we take a look at this class, we only have, okay, I think I have to run it. This one. So our adjusted bud contains just the last column, bud.adjusted. And then you can also change the column names. Okay, in this case, we did that. We use the function call names and then adjust bud. Now, adjust bud has only one column, so we don't have to identify the position of the column or which particular column we're changing. So we just write adj because we only have one column. So if I run this, It will print automatically. You have this column name already. Okay, clear so far, class? Would you kindly give me your feedback, please? If so far clear our discussion is clear. Thank you. So waiting for the others to give their feedback. I hope to get 100% response from you. Okay, how about the others? Okay, let's give you a few more seconds to react. Okay. All right. So always, class, when you do data analysis, you have to do EDA first. What does EDA mean? Exploratory data analysis. And one of the aspects of EDA, exploratory data analysis, is to plot your data. So here, just to shorten the name of bud, I just created this object bud1, okay, and bud1 is equal to adjusted bud. Okay, by the way, how do you call this class? This symbol here, how do you call it? That's your
Assignment operator po.
Yeah, thank you. That's your assignment operator, and it refers to it's just equivalent to equal to. And when you give names, when you're creating objects, it's better to use the assignment operator rather than equal, because it's also possible that while you're creating this object bud1, you might have in your in running your function another equal to here. Okay, you might have another equal. So that can cause some confusion because you have now two equals. Okay, so when we create objects, so we're assigning the name bud1 to adjusted one, and then we're plotting bud1, and just place the label here. Okay, I run this, and you can see here that our data, as we discussed last time, is not stationary. It's not stationary in mean because it has a trend. In fact, two phases here, an upward trend and even a downward trend. And for shorter periods, you have here upward, downward, upward, downward. So it's not stationary in mean. As far as stationary in variance, it might be very difficult to identify that. Okay, difficult to see if there's a fanning out or a fanning in of your data, but it doesn't look like it doesn't look like it's not stationary in variance. But the good news is that even if it's difficult to assess that visually, there are statistical tests that we can use in order to assess whether indeed our data is stationary in mean and in variance. Okay. The last time we learned another way to plot our data, ggplot2. So for your paper class, you will need to remember. That's why I required you to load data, because that's the only way you can do plotting. If your data if your output does not contain any data, what will you be able to plot? Okay, so you can use also ggplot2, and bonus points for those who will tap the functionality, other functionalities of ggplot2. Okay, so we ran this last time. Okay, and then we also learned that you can, that's why we created this object P1, and we printed this P1. So let me run this very quickly. And this generated a ggplot2. Okay, it's more robust, it's powerful, more powerful than just the plot function. But you can bring it to a higher level by creating a dynamic chart by converting your ggplot object P1 into a plotly object, which is a dynamic chart. Okay? If I run this, and we learned that last time that for the plotly object, this is dynamic. Okay, it contains each point here. We identify both the index and the value. Okay, you can see the date here, and the value. Okay, so it's easy to see here, for example, what could have been the lowest value. Okay, after the incident where they're where Mulvaney, the one they tapped to advertise, you can see here, 2020 0318, and the value is $33.8. As of last time, it has climbed to 59. Okay, but this is 2022 December, right? We didn't. By the way, if you don't add in the get symbols, if you don't add the dates, then quant mode will default to a specific opening date, start date, and the end date will be the latest closing date, the latest transaction date. The highest was at around here, 114. So I'm not sure about the timeline, but maybe this was the time when Dylan Mulvaney started advertising for Budweiser. That's 96, right? $96, and it went down to 33. So that's practically around 66 or 67% drop in the stock price. Okay. All right. Any questions so far, class? Any questions? Okay, how about the others? Any clarifications? Okay, thank you. Thank you so much, class. Thank you so much for your feedback. I really appreciate that. Okay, then also we said that quant mode also has its capability to plot. Okay, simple lang to, no? But the quant mode package has some pretty powerful plotting capabilities. Okay, but we won't go into that now. You may wish to explore how you can improve on this, okay, how you can add more features to this one. Okay. Right, so let me close that. Okay, so what we set out to do was to model our BUD prices. And the objective is to make use of ARIMA models. And we learned that the BUD, the BUD one, the adjusted the adjusted prices for BUD is not stationary. It's not stationary in mean, definitely, but we're not yet really sure if it's not stationary in variance. But it doesn't look like there's a issue with the stationarity in variance. There does not seem to be a constant fanning out or fanning in of your data. It's more erratic in that regard. Okay, so let me move this first. Okay, we said that the way to address the non-stationary in mean is to convert or transform your data. Okay, to address the non-stationary, the best way, one of the best ways, is to difference the data. Differencing means just subtracting your the value of your data at time t. You subtract it from the prior day if you're dealing with daily data. If it's weekly data, this week minus the week before. So when you're differentiating, class, you're generating a new object. So here I'm calling this dBUD, difference BUD, which is the difference of your BUD1. BUD1 is contains only your adjusted price. Okay, so if I run this dBUD, okay, and then review it, notice we said last time that there will be a missing value. There's a missing value because this first value here cannot be subtracted to the previous value. So there will be a missing value and a value here. And we learned last time that you cannot get a statistical metric for a data that has a missing value. If I run this mean of dBUD, It's an NA. Now that's good because R will force you to stop for a while and then take a look at your data. Instead of just automatically removing the NA, R will not do that. It means that you will have to do that yourself. So if we want to remove, or if you don't want to remove the missing data, but just remove it when you're computing, for example, for the mean, we can do this, NA.rm is equal to true. So in this case, you're maintaining the dbud data set, and then you're just computing for the mean by removing the missing value there, NA.rm. So if I run this, you notice now that there's a computed value, 0.009. Okay, a while ago, when we didn't remove this, it generated NA. Okay, now if I take a look once again at dbud, it still contains the NA, but we did not really remove the NA. It's still there. What R did was to get the average, but it disregarded the NA here. It removed the NA. Okay. So now it might be a good idea to remove the NA because I don't think there's any reason why we should maintain the NA there. So how do you remove it? We remove it by factoring it, by extracting that value. Okay, here dbud, we're using the same name. We just maintain the dbud. Is equal to dbud -1. Now, let me ask you, this was a question posted in the other section. Why is it that we're not putting a negative or a comma here? Isn't dbud, isn't it let's check the class of dbud. What happens when you're differencing class data? The original data, bud1, is an XTS. How about dbud, the difference data? So it's still an XTS object. Okay. So if you perform some operations on an XTS object, the result will still be an XTS object. Okay, so now why did we do this class? What will happen if we run this? Is this the correct function? Could you run this class and then see what happens? This was a question in the previous section which I want to share with you. What happens, class, when you run this code? Anyone who'd like to answer, class? What happens, class? Okay, Abi, why error? Why does it generate an error term?
Because I think, sir, diba, for this space, comma, it means that you want to include all the variables.
All the variables. So the empty, that one that has this one, it's empty, right? What does
Yes,
this
sir.
mean? What does this mean?
You want to get it from the all variables
All what?
that you
All
all I forgot the term. Wait lang, sir.
sige, sige. Anyone who can help Abi? What does this first value here refer to? It's your class. When you're filtering, when you're extracting value using brackets, what does this refer to? Pwede unmute na lang, class, para mabilis tayo. Yes, Miguel, thank you. This pertains to the row position, right?
Yes, sir.
So you're not putting anything here. It means that you're maintaining the number of rows. Okay, so same as islang rows. And then this one, it refers to columns, right? What does -1 mean? -1, class, means what? Adding or removing or what? Maintaining. -1 here means, class? Hello, class. Hello. Come on, we can do this. Alam niya. Sorry?
Remove
Sorry?
po.
Yeah,
Remove.
remove. -1, ibig sabihin i-remove. But when you take a look at your data, debug, what's the size of your data? It has 3,400 rows and only one column, right? So if you remove the column, what happens to your data? Nothing. So R will not allow that because removing the column, which is only one, you have only one column, will result to a non-data, right? Debug only has one column. If you remove the column, then what happens to your data? So that's why it generates an error term here, okay? However, if we just did this, okay, but why only one here? Only one because R understands that you cannot remove anything from the column because there's only one column. So what happens is that R will read this to be removing from the row. Now, can you remove lines from the row? Answer please, class. Yes or no? Okay, yes, thank you, Jerome. That was the answer a while ago, no? Yung removal of the column. Now, can we remove from the rows, class? Yes or no, please? Kindly chat. Okay, I hope we can answer faster, class. Can we remove from the rows of debug? Okay, definitely, class, yes. Why? You have so many rows. Debug has 3,400 rows, right? You know, 3,000, am I right? 3,000, 3,400, yes. So we can remove any row. Can remove the last row, can remove the first row. So here we're saying that -1, remove the first row. Okay, and why didn't we include? Usually when we filter, we also include the column. But in this case, there was no need to include the column because there's only one column. Okay, so R will perfectly understand that. Okay, what if you want to remove the last row? What do we do, class? If we want to remove the last row, okay, that's correct. No? Thank you, Joseph. You can write -3,400. Okay, you can write here -3,400 because that's the last row. And then Joseph identified here comma, okay, which means that the columns will be maintained. Or you can just write this one. It will give you the same answer. Okay, -3,400, or maybe a more elegant way is n row and bud 1. N row of dbud. Okay, the n row, class, will give us the number of rows of dbud. Okay, so you're removing here the dbud. So I think it's better to write this way rather than -3,400. Okay, any questions, class? So let me revert back to a -1, which means remove the first row. We want to remove that because that's an NA value. Okay, so let me run this, Control Enter, and then I check debug, there's no more NA value there. Okay, and then I can now get the mean, and it's the same, 0.0092. Okay, so let me stop again, class. Let me stop and ask your feedback. So far, clear? Any questions? Okay, I hope you don't mind me asking once in a while and requesting your feedback. Okay, so this time there was this question in the other section which I want to share with you because somebody asked there, is it can you decompose this one? debug. So he used that word decompose. Okay, so while we're here, while we're looking at time series, to decompose means to split your data into its components. That's what decomposition means. And I cited an example of the data air passengers. If you recall, class, we access data. Let's write here data air passengers. To access this air passengers, air there, air passengers. Okay, data air passengers. Let's run this, and it's a vector, right? It's here under the, not under data, but under values. This one. Okay, we looked at this last time. And okay, let's plot this. Let's plot this. I'll put it here. Here. Okay. So this is the air passengers data set data, and you can see here that it has a trend, okay, and it has seasonality, okay, and the variance is also seems to be not constant, okay, because there's a fanning out, and that's due to the seasonality. Okay, so we can decompose this. We can use the decompose function, and then I created this object D1, and then let's plot D1. And you can see now that the time series air passengers has been decomposed into its components. So this is the actual data set, the observed data set. This is the linear trend, and this is the seasonal trend. And then you have the random component. The random component is that part of your data set that cannot be explained by your trend nor by your seasonality. Okay. Now for our data debug, okay, did we plot this already? Okay. Our debug is difference, right? Difference data set natin yan. And let's plot this. Let's plot debug. And we can see here that debug is pretty linear, no? Which means that there's no trend. Okay, so what can we conclude out of this? What happens, class, when we difference our data? What happens when you difference your data? Okay, so become station. Yes, thank you. Thank you, Vincent. That's correct. Thank you, Jerome. It's correct. It detrends the data, okay, which is the same as saying it's stationary in mean. Okay, it detrends the data, it removes the trend, right? Okay. Now, let me go back to okay, the original data, the D. Let me just create this D2, which is, let's decompose the BUD1 data. Remember, the BUD1 data is your data of the adjusted prices, right? Okay, just to recall, if I plot BUD1, so there's a trend here, right? So the question was, can we decompose the BUD data set? So the question was really on the difference data set. But let's first decompose the original data set. Okay. So what do you see here, class? What do you see here? it failed to decompose. So there are limitations. Hindi siya na-decompose yung bud 1. All the more, class, all the more if we decompose the difference bud, it will give the same answer. Okay, so not all data sets, not all time series are can be decomposed. Okay, we were able to decompose the original air passengers data set. However, if we, okay, let me do this. So let me see if we can, T1 is minus, okay, I don't think we will be able to do this. Air passengers. Okay, so we now have, I'm creating T1 as an object for air passengers. Let's check where T1 is. So T1 is still, okay, I'm sorry. T1 is a character vector. So we cannot do this. We have to convert air passengers first into a data frame. Okay, so I'm not going to go into that now. Okay, I think I already explained. I just shared the question of the other section about decomposition. Okay, and in this case, we are not able to decompose difference bud. All right, so this is just another way, I think we discussed this also last time, to identify what will be deleted from your date difference bud. It's 2 colon n row dbud. So this is from row 2 up to the last column. So I just I just pointed that out. So it's the same as dbud -1. Okay. Now we move on to this. So as we said, we already have plotted this. The plot of dbud, the difference bud, tells us that we were able to address the non-stationarity in mean. So it no longer has a trend. Okay. All right. So the question is this already stationary? Can we now generate an ARIMA model for this? What's the question? What's the answer to that, class? What do you think? Is this now a stationary data? If it's already stationary, then that means that we will be able to perform ARIMA to generate an ARIMA model for this. So what do you think, class? Is this a stationary data or time series or not? Answer, please. What's your guess? What's your assessment? Class? Is the plot of the difference bud stationary? Not yet stationary. Okay, stationary. So we have differences in answers here. Okay. The good thing, class, is because visually we might not be really able to accurately determine whether your data is stationary or not. In this case, it looks like since the trend has been removed, it looks like the data is already stationary. However, the good news is that we will have to do statistical analysis for that. We will have to put it to a statistical test to determine if it's stationary or not stationary. But before we go there, let me just discuss this with you. If you get the log of the data, okay, okay. So here, what did we do? We get the we are getting the log of dbud and creating this object called ldbud, the log of the difference bud. If I run this, okay, now what happened, class? Why are not a number produced? Not a numbers, plural. What's the reason for that, class? Answer? Okay, there were negatives in dbud, therefore, so what's the implication if there are negative values in dbud? Implication is if there are negative numbers in dbud, you cannot get the log of the negative number. Okay, you cannot get the log of the negative number. Okay, so quickly, I don't want to, I can generate a log plot, but let me just use the internet. Okay, so let's see, plot of log of x. Let's go to Google and look at plot of log of x. Yeah, this one, class. We can use this. So this is the graph of log.x. And notice, class, the log of x is your domain, diba? The domain is the possible values of x. If we take a look at this, what are the possible values of x? This is your x. Notice that this plot actually is asymptotic with respect to the y-axis. So which means that this can go on and on and on and on, down, 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 up to infinity. Okay, it can have negative values of y, negative, infinity, negative, huge number, but it will not really touch this axis. It will not touch the value x is equal to 0. So that means that you cannot get the log of 0. Okay, if I do that in R, okay, let me run log of 0. What's log of 0, class? What's log of 0? Okay, only one's answering. Yeah. Log of 0 is infinity or undefined, no? So we cannot get the log of 0, but we can get the log of a very, very small number. Okay, for example, log of okay, log of 10 raised to the, say, 10 raised to the negative 1 million. So that's a that's a very small number. Okay, 1 raised to the 1 raised to the, no, sorry, it's 10. Because 1 raised to any number will still be 1. So that's 10 raised to the negative 1 million. It means that from 10, you move 1 million spaces to the right, to the left, I mean. Okay, to the left. So if you get this, the value here, it's infinite nano. So it's very, very small already. Okay. So if I, okay, if I make this, let's say, 100,000, 10 to the negative 100,000 means you move 100,000 places to the left. And what's the value? It's still infinite. Okay, let's decrease this a bit, about 10,000. Am I wrong? Tama naman. I'm just trying to get the log of a very small number. If it's 10 to the negative 1,000, 1,000. Oh, wait, huh? Log of, let me get a very small, just a very small number. Okay, there. So The domain are the possible values of x. So which means x can take on a very, 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 very small number. And the answer will be a very, 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 very small negative number. Because as you minimize this, okay, as you make this very, very small, okay, from the plot, you can see that your y value, your range becomes very, very small. I hope you're getting my example. As you decrease x, almost touching x is equal to 0, your y values becomes very, 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 very quote unquote large but negative, okay, because of the plot. Okay, so the domain of log of x is that x can only be greater than 0. It cannot be 0. Okay, so when we're dealing with, for example, getting the log of a time series, we cannot get the difference first and get the log, because difference in your time series will generate negative values. And we said for log of x, the domain is x should be positive. It cannot get the log of a negative number. However, for y, it can be negative infinity up to okay, up to a certain value. So the question is, can this reach up to a certain big number? For example, if you get the log, by the way, here, the log of 1 is equal to 0. You can see that here. The log of, let's try that. How about the log of a very, very huge number? Log of, let's say, 10 million. Okay. So log of 10 million is 16.1181. So even if you have a very, very huge number, say 10 to the 1 million. So that's very, very big. Okay. So here it becomes already a beyond the computing power of R. I think you will have to we can still tweak this so that it will get the value. Kasi 10 log of 10 raised to the 10 million. If you take a look at the plot, your 10 million is way, 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 way to the right. So, okay, your data will behave in such a way that it will not reach a limiting value. So we'll just keep on going up and up and up and up and up. Okay, so I hope enough said about the log of a number. We'll need that in a while when we discuss the returns. Okay, which is in a few minutes. Okay, wait, what happened again to my mouse? Okay, let's go here, yes. Okay, so if there's a need for you to get the log of a number because of non-constant variance, okay, getting the log of a number, your time series, for example, this one. So here we're getting the log of bud 1, which is the adjusted price. If we get the log of that first, and then get the generate this LBUD data, okay, I'll run that. So this is the log of that number. And then if I plot that, I'll plot this one. Plot the log of bud. Okay, take a look at the result. We got the log of the time series, okay, and plotted it. Would you like to comment what happened, class? Are we able to address the issue of non-stationary in mean? In other words, class, by getting the log of the time series, are we able to transform the data into a stationary data in mean? Answer, please. Okay, no. About the others, I noticed that only a few now are answering. Were we able to address the stationarity in terms of mean? I only have a few answers. How about the others, please? Okay. All right. Thank you. I hope I don't need to remind you, please, to participate, even just by answering. Okay, so we're not able to address the uh, non-stationarity in terms of the mean just by getting the log of that series. Getting the log might address the non-constancy in variance, but it will not address the non-constancy in mean. Okay, so what do we have to do? Aside from getting the log, we will have to get the difference. So this now is the L bud. Remember, L bud is the log bud. And then when we get the difference of the log bud, this will be okay. Okay, this will be okay because if you're just getting the difference of your time series, there will be no restriction. There will be no restriction. You can subtract the negative from the negative, etc. Okay, now, so we now have this DL bud, and then this DL bud, which is this one, also has an NA value. Okay, why does it have an NA value? Because you are subtracting. Right? When you subtract that, there will be a missing value there. So we can remove the missing value. We can make use of this. Okay, a while ago we use subsetting, right? By doing the negative one. Here we can just write NA.omit. If I run this NA.omit, okay, it removes the missing value. Okay, and then once we have that class, if we plot this, if we now plot the difference of the log bud series, what do we have? And how does this compare with the difference, the plot of the difference bud? Would you comment, please? Comment, please. How does this compare with the difference bud, D bud? This is the DL bud. Okay, let's go back to the difference bud class. I don't think I forgot to discuss this with you. So this is the function. This is the plot of the difference bud. We notice that this is as we said, this is stationary in mean, right? Stationary in mean siya. It does not have a trend. It's not going up. Neither is it going down, right? So no trend. So stationary in mean. However, you can see here some spikes or shocks. We call it shocks. Or another name for this is what you call volatility clustering. What is volatility clustering? Volatility clustering indicate that these are times when prices either tend to go up and continue going up. So an increase will lead to another increase, another increase, another increase, another increase. Okay, while a decrease will lead to a decrease, another decrease, another decrease, another decrease. So for example, these are now your volatility clustering. It indicates that your stocks were, the value of BUD was going down, and it continued to go down and down and down and down and down. In this case, these are volatility clustering where the trend was to go up. This one going down. Okay, so these are what we call volatility clustering. These are shocks to your data. So that's how we characterize this one, difference bud. Okay. Now, how does that compare, class, with this one? The difference log bud. Is there any difference in how they look, class? Comment, please. Comment, please. Okay. We have a comment here. Yes, thank you. Thank you, Vince. You have your data. When you plotted your difference of log bud, notice that it has less shocks, right? It has less shocks. So what the getting of the log did was to reduce the volatility clustering, reduce the non-constancy, the volatility of the data, which has something to do with the variance of the data. So that's what it did. Okay, so which model to use? Is it difference of bud or difference of log bud? Okay, so the test there is, if the difference bud series is already stationary, then better use that, because the difference log bud is less shall we say more complex because of the additional step. And remember that when we're forecasting, we will have to revert back to the original data. So having these two transformations will mean that you will have to do two steps before you can convert your forecasted values into the original values, as compared to having only one retransformation. Because for your difference bud data series, okay, how do you convert it to the original? You add consecutive numbers. Okay, because to get the difference bud, you subtracted. So you will have to reverse that and then add. Okay. However, there's a financial implication for the difference. This is the difference in log bud, right? I'll explain in a while. Okay, the difference in log bud actually is what? What do you think is this data? What did you learn in your previous finance? What happens when you get the log and then get the difference? What's this? What is this data? And it has a very important implication or important role in finance. In fact, maybe for some of you, your paper will be about this, the difference of the log of the data. Because this one, class, is what? This one is, anyone? Can anyone guess what this data is? When you get the log and then you get the difference, what is that data? What are you getting? You get what? This one, class. What's this? Getting the log and getting the difference is actually equivalent to anyone, please? Any guess? Any suggestion, class? Okay, I see an answer. What's the answer here? Okay, thank you, Christine. You're correct. No? This class, the difference of the log of our data is actually equal to the log returns of the data. Okay, let's compare, class. Let's compare. Okay, and in finance, oftentimes what you model is not the prices, but what you model is the returns. So getting the difference of the log of the data is very important when you're looking at the returns of the data, the log returns of the data. Okay, so here we're looking at the function here, daily returns. So let's view this. Let's seek the help. Daily ret. Okay, daily returns, this function comes from your quant mode. Okay. Okay, here, class. So this is very important for us because in quant mode, you can get the period returns. Period means either daily or weekly or monthly, etc. So this help is very important. So you can use period return. X is your time series, and then period it can be monthly, weekly, daily, etc., or yearly, and then the type can either be logarithmic or arithmetic. Okay, so in finance we use more the logarithmic returns, the logarithmic way of computing returns, and I hope you have learned that before. But if not, class, kindly review what's the advantage of using logarithmic returns versus arithmetic returns. Okay, and there. So you can use either the period returns or this one, daily returns directly, weekly return, monthly return, quarterly return, annual return. So this, and you can use the all returns function. All returns function will give you the returns both daily, monthly, weekly, etc. If for our purposes, we just want to make use of the daily returns and compare that with the difference log of your data series, of the time series. Okay, so let's run this. Let's create this object ret, and we're going to use the daily return object, and the object is bud1. Okay, we're getting the returns of the original data set. Okay, the adjusted price. Don't make the mistake of getting the DL bud, because DL bud is already the returns. So you're not getting the returns of the returns. So you're getting the returns of the original data set, the adjusted price, and then here type is equal to log. Okay, the option is type arithmetic. Okay, but as I said, the daily log, the difference log of a data series, the time series, is equivalent to the log returns. Okay, let's get this, class. So we're creating this object called ret. Control Enter. Okay, and now I have this ret object here. Okay, which is also an extensible time series object. And then if I print ret, okay, so here is ret. Notice now that there is this 00 value here, which is actually equivalent to NA. Okay, because getting the log returns is actually equal to, the formula for that is get the log you get the log of your P sub t over P sub t minus 1, and then subtract 1. Okay, so this is the returns. Okay, the daily returns, log returns. Okay, let me close this. Okay, so what we do here is, okay, we have some more minutes. Let's remove the first. Let's remove the first row. So return -1, and then notice now that it removed the first value, which is NA or 0000. Okay, can you now compare, class, the ret object? How does the ret object compare with the? Can you please check? So compare the ret object. Compare it with the DL bud object. So can anyone answer, please? How does the ret object, the one that we created, how does it compare with the DL bud object? I hope you were following, class. So the question is now, okay, Tristan, can you unmute yourself and please explain? Did you compare the values?
Yes po, sir. It's both the same po. Same outputs po siya, sir.
So same output, okay? So class, are you now convinced that the difference of the log of your time series is equal to the daily returns, daily log returns, class. Kasi if we use arithmetic, iba yun. Iba. So the difference of the log series of a time series is very important because it represents the returns, the log returns of that series. And then, as I said, in finance, many of the studies, many of the models are not focused on the prices. You're not looking at the price, but you're looking at the returns. Okay, we're analyzing the returns of the time series and not the prices itself. Okay, so let's go back here, and then I have a few more minutes. Okay, before we end here. Okay. All right, here, class. Here. So let's now test. Okay. Remember, we did two objects. First is the difference of the bud, and then difference of the log of bud, which is just the same as note that DL bud is equal to ret. Right? We were able to prove that. So let's use the augmented Dickey-Fuller test. Okay, what's the augmented Dickey-Fuller test? The augmented Dickey-Fuller test is supposed to test whether our data is stationary or not. And the null hypothesis is that the time series has a unit root. We'll discuss this next meeting. What does this mean? What do you mean by has a unit root? Loosely speaking, it means if your time series has a unit root, it means that it's not stationary. But we'll explain this in greater detail next time. Okay, so let's use from the T-series package, you have this ADF.test, which is augmented Dickey-Fuller test. Let's first test the D-bud, the difference bud series. And if we test if it's stationarity or not, we can see here that the p-value is 0.01. And what's the implication? Class, what's the implication? Annotate ko lang. So the rule is, class, the rule is when the p-value is low, when the p is low, the null must go. Okay, so for me, this is a easy rule to memorize. When the p is low, p is a p-value, right? Low means usually it's less than 0.05. That's a standard. The null must go. The null must go means you reject the null hypothesis. So in this case, our p-value is 0.01. So it's less than 0.05. Okay. Therefore, we are going to reject the null hypothesis. What's the null hypothesis? Our time series D-bud has a unit root. And having a unit root means it's not stationary. Not stationary. So what's our conclusion? We reject this null hypothesis that D-bud is not stationary. Okay, the alternative is that it's stationary. So we have strong reason to believe that our data is we have strong reason to believe that our data is not stationary. Ergo, stationary siya. So if we also check, class, it's it's already time, class. So I hope you can give me a minute. I'll just finish this. Okay. How about, class, this one? Okay. How about the difference of log bud? Okay. If we check this, we also get the same thing. The data is difference of the log bud is also stationary. So that brings us the question, what should we use? Is it the difference bud or the difference log bud? Okay. Theoretically, class, it would be better to use the difference bud because it's less complicated. Okay. However, if you're looking at the returns, of course, we have to get the log because DL bud is the returns of the data. Either use DL bud or the ret object. Okay, so it depends really on what you're studying. If you're just studying the price of the data, then you can just use the D-bud, the difference of the data. And then there's another test. I'll leave this to you, class, yung KPSS test. So I'll just run this KPSS test. And here the null hypothesis is the opposite for ADF test. The null hypothesis here is that the data is stationary. And when we run the KPSS test, the p-value is 0.1. Therefore, we fail to reject the null hypothesis that the time series is stationary, because that's the null hypothesis. So indeed, based on the ADF test and the KPSS test, it shows us that the data, T-BUD and the DL-BUD, for this one, run natin, also this one, p-value is 0.08. Therefore, we fail to reject the null hypothesis that the data is stationary. The data is stationary. Okay, so for next meeting class, we're going to look at the another test, unit root, that degree of freedom test. And also we're going to now look at the autocorrelation function, partial autocorrelation function, and we'll be modeling ARIMA already. Okay, and hopefully by next meeting, we're done with the ARIMA. Okay, let me stop recording.